Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of EC of RMD Engineering College. In today's session, we are just going to see one foremost important topic of VLSI design, that is stick diagram. A short revisit to that. In today's session, we are just going to concentrate what are the various mass layers and the fundamentals of stick diagram. What's the need for stick diagram? What does a stick diagram actually indicates? What are the basic rules in drawing a stick diagram? And a few examples over there. Yes, totally we are having four categories of mass layers. One is going to be N diffusion, P diffusion, polysilicon material and metal. Right. So getting into the stick diagram, actually the stick diagram is a cartoon of a layout. So a layout in the sense we are just going to have some topographical as well as the layer wise information present over there. So a stick diagram is going to be a cartoon representation of the layer. So as I have as I have mentioned already, as a cartoon network, it does not shows the exact placement of the transistor, size of the transistor, number of wires used, wire length and wire width, etc. Actually, it just show what are the components and what are the possible contacts that has been made in that particular layer. So that can be visualized using this stick diagram. Yes, the key idea behind the stick diagram is stick figure cartoon of a layout. So such stick diagram plays a vital role in making the planning layout. So that is, I could find out where the transistor can be placed, assignment of the transistors, everything can be identified. So before getting into the stick diagram, let us see to that some labels. We have mentioned four major layers. One is the N diffusion, P diffusion, polysilicon material and metal. In order to indicate the P diffusion, we can make use of a yellow color line, that is yellow color stick. For N diffusion, we are using a green stick. For polysilicon material, a red stick. For metal contact, one can use a blue color stick. Right? So, and this line indicates demarcation line. So, demarcation line in the sense, it actually segregates the operation of a PMOS transistor and a NMOS transistor. Right? So, this bubble indicates contact cut. So, contact cut in the sense, it just shows whether there is some interconnections over at that point or not. So, if it is going to be a buried contact, we can have a brown color dot, right? And this yellow color square indicates it is an N implant. So, whenever we are going to draw a depletion type of NMOS transistor in dot, we will be making use of such N implant. And this black color cross indicates substrate contact. Both at the top, at the bottom, you have to indicate this substrate contact. Okay, as we all know, for a MOS transistor, we are having four terminals: gate, source, drain and substrate. Right? So that substrate contact has to be mentioned by this black color cross. Apart from that, if you are having a polysilicon material over the P diffusion, it will function as a PMOS, simply enhancement transistor. If suppose this polysilicon material is placed over a N diffusion, it will function as NMOS, enhancement type of transistor. Then, if you are having this yellow color square over this polysilicon and N diffusion in the sense, it meant that we are having depletion type of transistor. That is NMOS depletion type of transistor. Next, let us see some rules for drawing the stick diagram. Right? As we have told already, blue color indicates metal part and red color indicates polysilicon material. Right? So if two or more sticks of same type crosses each other, it represents an electrical contact. By default, it will be having some electrical contact. There is no need to make an external contact symbol over here. Okay, whenever we are taking two or more sticks of similar category, by default there exists a electrical contact over there. Right. Coming to rule number 2. So blue color indicates your metal contact and red color indicates your polysilicon material. That is, here you are having two sticks of different material touching each other. So actually speaking, here there is no electrical contact. Okay, you could see here there is no electrical contact. So what is the difference between these two in the sense, whenever a dot is made, right? Whenever a dot is made between the two different material, we can come to a conclusion, a contact is present explicitly. Clear? Coming to rule number 3. So we know this red color line indicates a polysilicon material. When a polysilicon material crosses a p diffusion, it will function as a PMOS transistor. Just now we have seen to that. Similarly, when a polysilicon material crosses over a yellow color line, that will act as a PMOS transistor, and this will function as a NMOS transistor. Both the things are going to be in enhancement mode of operation. Right? Here we should not indicate a contact. If a contact is mentioned, then it will not function as a transistor. Right? If a polysilicon material lies over a green color, that is N diffusion, it will function as a NMOS transistor. And when a polysilicon material touches your yellow color line, okay, so it will represent your PMOS transistor. Right? Now let us see one example how to draw a NMOS transistor. Right? So if you could see the diagram, here I am having a depletion type of NMOS transistor and this is enhancement type of NMOS transistor. Right? So and moreover, we could see this is called a pull-up network and this is called a pull-down network. Since it is connected to the supply VDE, it is called a pull-up network. Here it is being connected to the ground, taking the output towards the low level. Hence it is called a pull-down network. The input is applied to the gate of a pull-down network, that is enhancement type of NMOS transistor, and the output is taken across depletion type of NMOS transistor. Right? The first and foremost step in drawing the stick diagram is draw the VDD and ground. Since both are metal, just draw by a blue color line, leaving some space so that I want to fit in the remaining components present in the layout. Next, we are drawing a NMOS transistor. For NMOS, I have to draw a green color over this metal part. Right? And then I have to connect a polysilicon material. We are having two transistors, one depletion NMOS transistor, one is enhancement NMOS transistor. That is, we need to connect two gate terminals, and that's why we have connected two polysilicon material, that is red color stick lying over your N diffusion will function as a NMOS transistor. So in order to indicate this is enhancement, this is depletion, what we have to do? We have to show it by a yellow color square. Right? This yellow color square indicates this transistor is depletion mode of NMOS transistor. Right? As we have told already, the input is given to enhancement mode of NMOS transistor and output is taken across the depletion mode of NMOS transistor. So in order to take it, we are just making a metal contact, that is we are indicating by a blue color line for your input voltage and your output voltage. Right? So you understand how to draw a stick diagram, right? By following few rules we have stated now. Have a nice day. Thank you.